6.7. Probability and odds. The objective of this lesson is to find probabilities, which just means the likeliness of an event occurring. Okay, so the vocabulary words. Outcomes. The word outcome just means all the possible results of an experiment. For example, if I roll a number cube, I would get 1, 2, 3, 4, 5, or 6. These are all the possible results. An event is what I want, and an outcome or a collection of outcomes. Okay, so for example, if I want to roll a 1, then it will be only one possible chance. Okay, and if I want to roll an odd number, it will be 3 possible chances. And then, so event is just what I'm expecting to get from my experiment. Okay, and the third word, favorable outcomes, this means the desired outcomes for an event. Example, if I want to roll an odd number for a cube, 1, 3, 5 would be all my favorable outcomes. Okay, let's talk about probability of an event. When all outcomes are equally likely, then the probability of event equals to the number of favorable outcomes, okay, and over the number of possible outcomes. Okay, so for example, suppose you roll a number cube. What is the probability that you roll an even number? First of all, your total possible outcomes are 1, 2, 3, 4, 5, 6. So a total of 6 possible outcomes. Then the probability of rolling an even number. So rolling an even number is your event. Equals to 3. 3 is your favorable outcomes. Okay, you only have 1, 3, and 5. Okay, in a number cube. And then you got to put it over the total possible outcomes, 6. Okay. You see how your vocabulary terms are coming together? Okay, so 3 over 6 in simplest form would be 1 over 2, and that would be your answer. The above example that I just explained is called a theoretical probability because it's based on knowing all the equally likely outcomes of an experiment. There's another kind of probability, and we call that the experimental probability. This is the probability that is based on repeated trials of an experiment, meaning a person keeps on doing the same thing over and over again. Okay, so each trial in which the event occurs is called a success. So of all these trials, when it does happen, okay, then it will be called a success, meaning this person got it. Okay, so here's our representation for an experimental probability, the number of successes over the number of trials. Okay, let's read this word problem to the right. You interviewed 45 randomly chosen students for the newspaper. So I went around and interviewed 45 people. That means I've been doing this repeatedly. Because I've been doing this repeatedly, that's why it's considered trials. Okay? Of the students I interviewed, or you interviewed, 15 play sports. So I am trying to find people who play sports. And when I do find people who play sports, then it's a success. Okay? Find the experimental probability that the next randomly chosen student will play sports. So, like I said earlier, I want my success to be that the next person interviewed would play sports. So, 15 will be my number of successes. So, I will put P of event equals 15 over 45, and that would equal to 1/3. So, as you can see, this lesson is mostly about understanding these vocabulary words. And once you understand them, these word problems are really, really easy. Okay? Next, I will briefly explain how to interpret probabilities. probabilities can range from 0 to 1. So your answer can never be less than 0 or more than 1. The closer the probability of an event is to 1. Meaning, if you get a probability that equals to 1, then yes, the event is very certain. The more likely the event will occur. However, if you're more leaning towards 0, then the event is impossible. And if you get any probability in between 0.5, then the probability that it will occur, or the probability of an event that will occur, is half the time. Okay, the next vocabulary term I would like to introduce is odds. So there are two types. There's odds in favor of an event and odds against of an event. To find the odds in favor of an event, you will set it equal to the number of favorable outcomes over the number of unfavorable outcomes. And to find the odds against of an event, you will set that equal to the number of unfavorable outcomes over the number of favorable outcomes. Basically, they're switched. So let's take a look at an example. Example, finding the odds. Suppose you randomly choose a number between 1 and 20. A. What are the odds in favor of choosing a prime number between 1 and 20? So let's take a look at the solution for part A. There are 8 favorable outcomes: 2, 3, 5, 7, 11, 13, 17, and 19. All these outcomes are prime numbers, okay? And 20 minus 8 equals 12 unfavorable outcomes. So my odds in favor will be equal to 8, which is my favorable outcome, over 12, which is my unfavorable. The other 12 numbers are composites. Okay, so then I need to simplify 8 and over 12, and that will be equal to 2/3. Okay, so let's look at part B. What are the odds against choosing a prime number? Part B, the odds against choosing a prime number are 3/2. I just simply take the reciprocal of part A, 3/2. Okay, let's do some guided practice problems. Part A, theoretical probability. Suppose you roll a number cube. What is the probability that you roll a number greater than 1? Okay, so my event is rolling a number greater than 1. This is my event. Okay, I'm going to set it as probability rolling a number greater than 1. And my total possible outcomes are 1, 2, 3, 4, 5, 6. So I have 6 possible outcomes. So I'm going to put that in the denominator. And of these 6 numbers, 5 of them are greater than 1. So I would put that in the numerator, and this would be my answer. Okay, part B, experimental probability. Remember, experimental probability means the number of successes over the total number of trials. So we usually use this probability to make a prediction. Okay, let me read the word problem. You attempt 50 free throws and you make 32 of them. Okay. So I can represent this event by putting 32 in the numerator over 50. 50 will be the number of trials. 32 will be my number of successes. Okay. Use the experimental probability to predict how many free throws you will make tomorrow if you attempt 75 free throws. Okay, so we need to set up a proportion to find our answer. So I know that 75 would be my trials, total number of trials for tomorrow. And I need to make a prediction of how many free throws I will make by putting X in the numerator. Okay, so now I need to simplify. 50 with 75 be 2. 75 divided by 25 will be 3. And then I can simplify 32 with 2. 2 divided by 2, 32 divided by 2, 16. Okay, and then I can cross multiply. 16 times 3 is 48. And this will be your answer. 48 free throws. Finding odds. Okay, to the right I have a spinner. And my questions to the left asks you to find the odds in favor of stopping on a multiple of 4, as well as the odds against stopping on a 1 or 2. Okay, let's first look at the first question. Remember, the odds in favor means that you want to set it equal to the favorable outcomes over unfavorable outcomes. Meaning, in the numerator, you're in favor. In the denominator, you're not in favor. You don't want it, okay? So, in the numerator, I would put 2 because I only have 4 and 8 as my multiples of 4. And in the denominator, I would put 6 because I have 1, 2, 3, 5, 6, 7 as my unfavorable outcomes. I don't want these, okay? And now I can simplify this to get 1/3. Okay, let me erase this. Okay, let's take a look at the second question. What are the odds against stopping on a 1 or 2? So odds against, remember, it's equal to the number of unfavorable outcomes over the number of favorable outcomes. So I am in favor of stopping on 1 or 2, so there are 2 possibilities, okay? But I am looking for the odds against stopping on 1 or 2. So there are 6 possibilities, 3, 4, 5, 6, 7, 8, that will prevent me from stopping on 1 or 2. So I need to put 6 in the numerator, okay? And then I can simplify. My final answer is 3 to 1.